There are moments in astronomy when the universe behaves so strangely that even seasoned scientists begin to feel as though the cosmos is deliberately messing with us, and right now, 3I Atlas is doing exactly that. As this interstellar visitor races closer to Earth, closer than it has ever been since we first spotted it, the object isn't calming down like a normal comet drifting away from the sun. It's not fading, it's not settling, it's not becoming predictable. Instead, every new observation only deepens the mystery. Anti-tails pointed at the sun that shouldn't exist, mass loss calculations that make no physical sense, jets that appear too organized for natural outgassing, brightness patterns that should be impossible for a rotating nucleus covered in a freely expanding coma, and now, sudden trajectory adjustments that align almost perfectly with one of the most strategically useful gravitational locations in the solar system. As we count down the final days before its closest approach, one thing is becoming painfully clear. The closer 3I Atlas gets to us, the stranger it becomes, and the more it forces us to ask whether we are witnessing nature at its most extreme, or something else entirely. As the video begins, 3I Atlas is just 18 days away from reaching the closest point to Earth that we will see during its entire observation arc, coming in more than twice as close as it was when the Hubble Space Telescope produced the now iconic image that ignited global fascination. But unlike typical comets moving away from the sun after perihelion, 3I Atlas isn't dimming in the way it should. Months ago, when it was still far from the sun, it was already brighter and more active than expected. Now, with Earth approaching a new geometrical vantage point, the world's most powerful observatories, including Hubble and James Webb, are preparing to lock onto it again. Yet even before these elite telescopes gather fresh images, amateur astronomers around the world are capturing an avalanche of details that were never supposed to exist, and that alone is raising the stakes for what December's encounter may reveal. The capabilities of amateur astronomers have taken center stage in this unfolding saga because backyard astrophotographers using surprisingly compact telescopes are capturing images of 3I Atlas with clarity that puts to shame the spacecraft orbiting Mars, which we had hoped would obtain spectacular views during the object's flyby. The community-driven imagery isn't just beautiful, it's transformative. It has revealed features so striking and so physically improbable that global observatories have begun recalibrating their December observation schedules. What makes this even stranger is that these anomalies didn't appear gradually. They erupted into view as if the object flipped a switch at perihelion, refusing to behave like any known comet and hinting at a deeper, more unsettling origin story. Among all the anomalies surrounding 3I Atlas, the anti-tail remains the most shocking because unlike typical comet tails, which always point away from the sun due to solar wind, this one is a needle-like jet pointing toward the sun for at least 1 million kilometers. And unlike classic optical illusions that produce temporary anti-tails only when Earth crosses a comet's orbital path, this object's anti-tail cannot be a trick of perspective. The document makes it clear: Earth never crosses 3I Atlas's orbital plane. That means this structure is real, physical, and violently contradicts our understanding of solar-wind interactions. Dust or gas emitted from a natural comet should be shredded instantly by a 400 kilometers per second solar wind, the astrophysical equivalent of trying to walk into a 5,000 kilometers per hour hurricane. Yet 3I Atlas not only resists this solar gale, it forms a coherent, organized line through it. This alone would make the comet unprecedented. Combined with everything else, it becomes almost unbelievable. Astrophysicist Avi Loeb ran the numbers, and the physics becomes almost disturbing. For the anti-tail to maintain its structure at such a distance from the sun, its density must exceed the solar wind's density by a factor of 1 million. At that density, 3I Atlas should be shedding mass at a catastrophic rate, hundreds of tons per second, billions of tons over the course of 2 months. That is 10% of the object's entire minimum mass lost in a matter of weeks. And yet 3I Atlas remains intact, not cracked, not fragmented, not even noticeably diminished. A natural object undergoing this degree of erosion should be obliterated. So why isn't this one? According to Loeb's calculations, 3I Atlas should no longer exist if it were producing this anti-tail through natural outgassing. Even NASA's lower mass estimate makes the paradox more severe. If NASA is correct, and the nucleus is much smaller than Loeb calculates. Then 3I Atlas should already be gone, its solid core vaporized by the very processes that appear to be shaping its enormous sunward jet. And yet the object is not only surviving, it is becoming clearer, more structured, and more organized as observers continue tracking it. Something is providing coherence to the dust column, either extreme density, extreme confinement, or a mechanism that doesn't appear in any comet textbook. During the summer, 3I Atlas behaved like a rock. Its trajectory was predictable, stable, and completely free of non-gravitational acceleration, the tiny boosts caused by uneven outgassing on natural comets. But near perihelion, at the exact moment when no telescope could see it, everything changed. A measurable non-gravitational acceleration appeared in the data. This should require more than 10% of the comet's entire mass to be expelled as gas, yet we already accounted for that amount simply to explain the anti-tail. In other words, the math doesn't close. The comet cannot lose this much mass without disintegrating, yet the acceleration is clearly present. Something else is pushing it. Here is where things become deeply strange. If the non-gravitational acceleration comes from gas jets, we should see interruptions in the jet structure every 16 hours as the object rotates. Instead, the jets remain continuous, collimated and laser-like. The object spins, yet the jet does not pulse. A natural comet cannot produce a perfectly stable, continuous jet unless the outgassing comes from a single fixed point. But if that were true, we would see the regular heartbeat pattern in the antitail as the nucleus rotates. Instead, we see no breaks. The jet behaves as though the object isn't rotating at all, even though it is. Something about the emission appears decoupled from rotation entirely. Brightness variations between 10% and 20% appear every time 3I Atlas completes a rotation. But according to NASA, the brightness comes overwhelmingly from the coma, the cloud of gas surrounding the object, which should not rotate with the nucleus. A rotating nucleus cannot drag the coma with it. And yet the brightness fluctuates with rotation, implying that either the coma is rotating or the nucleus is interacting with the coma in a way completely inconsistent with standard comet behavior. The document's analysis highlights clear brightness changes in Ray's astrophotography sequence, variations that should be impossible under NASA's assumptions. At this point, 3I Atlas has demonstrated so many contradictions that NASA's "it's just a normal comet" position begins to ring hollow. The object acts like a comet in some ways and a rigid, structured, energy-driven craft in others. Rather than embracing the anomalies and showcasing the discovery, NASA appears to be minimizing them, even as independent astronomers continue to publish evidence of phenomena that defy known physics. The document makes a clear point. NASA should be thrilled about this. They aren't. Why? Then comes the strangest coincidence yet, one that borders on impossible. On March 16, 2026, 3I Atlas will pass extraordinarily close to Jupiter at a distance nearly identical to Jupiter's Hill radius, the gravitational boundary where Jupiter's influence overcomes the Sun's. This location is strategically ideal for placing orbiters or probes for long-term observation of the Jovian system. A natural comet accidentally intercepting this zone is already unlikely, but the match is so precise, so perfect, that Avi Loeb reached out to JPL for comment. NASA did not respond. Within days of Loeb's inquiry, NASA quietly revised its non-gravitational acceleration estimates, reducing the anomaly by a factor of 6 and shifting the predicted closest approach distance just barely outside Jupiter's Hill radius. The timing raised immediate suspicion. Why did NASA make such a drastic revision only after being notified of the coincidence? And why wasn't the change accompanied by any explanation? The revision pushed 3I Atlas from a direct interception of Jupiter's gravitational boundary to a near miss. But the object's actual path has not changed. Only the model has. Loeb responds with an analogy that hits harder than any accusation. When the Vatican insisted Earth was the center of the solar system, the planets didn't change their orbits. Just because NASA changes its model doesn't mean 3I Atlas changes its path. When the object reaches the Jovian system in March, reality will decide who is correct, not JPL's spreadsheet, and amateurs will be able to measure it themselves. If 3I Atlas were using chemical or ion propulsion, everything suddenly makes sense. Ion thrusters produce exhaust velocities thousands of times faster than natural outgassing. This drastically reduces the mass requirement for creating non-gravitational acceleration. It also explains the laser-like jets. It explains the lack of rotation pulsing. It explains the stability. It explains the brightness variations. In short, an engineered mechanism fits the data better than natural physics. And that's exactly why the scientific journals refuse to publish the analysis. The anti-tail's coherence hints at structural organization, perhaps magnetic confinement, perhaps an engineered exhaust plume, perhaps dense metallic particles aligned along a field we cannot yet measure. Natural dust should scatter, broaden, and collapse almost immediately, but the anti-tail persists for days. This persistence suggests a sustained, controlled mechanism or a material with extreme density aligned by a non-random force. Whether natural or artificial, 3I Atlas behaves as if it is maintaining a stable, carefully tuned trajectory, resisting solar wind, shaping jets, producing symmetrical thrust, and perhaps preparing for a gravitational maneuver around Jupiter. This is not proof of intelligence, but it is proof that the object's behavior fits no natural category we currently recognize. Every day brings a new anomaly, a new image, a new jet pattern, a new brightness fluctuation, a new orbital irregularity. And now, with just days remaining until its closest approach, 3I Atlas is accelerating the pace of its weirdness. This is no longer just an interstellar object. It is a problem, a paradox, a visitor rewriting the rulebook in real time. And as it draws nearer to Earth, the universe feels like it is leaning forward, whispering that something extraordinary is about to happen. As astronomers continue to stack nightly observations of 3I Atlas, a new pattern emerges, one that deepens the crisis around the object's physical behavior, because the sunward jet that appeared stable, narrow, and impossibly structured does not display the rotational modulation expected from any cometary nucleus. The document makes this contradiction unavoidable. The jets remain aligned, coherent, and uninterrupted, even as 3I Atlas completes full rotations. For a natural comet, rotation is the great disruptor. As the nucleus spins, active vents sweep across different angles, producing pulses, arcs, and discontinuous patterns in any dust or gas stream. Yet 3I Atlas behaves as if the rotation simply does not matter. The jet does not waver. It does not pulse. It does not curve. It does not shift intensity in a way that corresponds to any rotational cycle. This forces analysts to confront an interpretation far more troubling than the anti-tail structure alone, because if the jet is genuinely independent of rotational geometry, then either the outgassing is occurring in a way that compensates for rotation with unnatural precision, or the mechanism producing the jet is anchored to a field, a pressure system, or a confinement structure that is not physically attached to the rotating nucleus. And this last possibility is what has begun to circulate quietly within the technical circles studying the object. If the emission pattern is bound to a stable reference frame that the nucleus is not dragging with it, then 3I Atlas is not behaving like an icy fragment. It begins to resemble a system, something capable of decoupling its rotational state from its emission state. And while no one in the mainstream is willing to say this directly, the data leaves no easy escape. The jet behaves as though rotation simply doesn't apply, a signature that fits no natural comet model in existence. By late November, the scientific discussion surrounding 3I Atlas has shifted from isolated anomalies to an emerging synthesis that is far more unsettling, because the document makes clear that none of these strange behaviors, non-gravitational acceleration without visible mass loss, brightness variations synchronized with rotation despite a dominant coma contribution, an anti-tail requiring physically impossible density levels, stable jets that ignore rotational dynamics, and a suddenly meaningful approach toward Jupiter's Hill sphere can be treated as independent quirks. When examined together, they form a pattern suggesting that 3I Atlas is governed by a mechanism or physical state that does not belong anywhere within the standard taxonomy of comets. Every natural explanation collapses under the weight of another contradiction. If the object is small, it must be losing catastrophic amounts of mass. It is not. If the object is large, it cannot produce the precise acceleration observed. It does. If the coma drives the brightness, it should not follow rotational cycles. It does. If the jet is natural, it must pulse. It does not. If the orbit is purely gravitational, the Jupiter coincidence is absurdly unlikely. It happened anyway. And this is why, as the object accelerates toward its closest approach, professional and amateur analysts alike are beginning to echo the same quiet thought. Maybe this is not a normal physical category at all. Maybe we are confronting not a bigger version of what we already know, but the first clear example of something that belongs to an entirely different class of interstellar objects. Something that forms structures we do not yet understand. Something that interacts with rotation, sunlight, and gravity in a way that makes our existing models look primitive. And the closer it gets to Earth, the more the universe seems determined to make sure we notice. And now, as we stand just days away from the closest approach of an interstellar visitor that refuses to behave like anything we have ever seen, the truth pressing against the edges of this mystery becomes almost impossible to ignore, because 3I Atlas is not simply unusual or quirky or unexpectedly active. Its behavior forms a coherent pattern of contradictions that collectively challenge the foundation of everything we thought we understood about comet physics. The anti-tail alone should have rewritten the playbook, a perfectly straight, sun-facing structure that defies solar wind dynamics and demands densities so extreme that any natural comet would have torn itself apart long ago. Yet 3I Atlas remains intact, structured, and alarmingly stable. The mass loss equations contradict the survival of the nucleus. The non-gravitational acceleration contradicts the absence of visible jets. The continuous jet alignment contradicts the rotation that should slice it into pulses. The brightness fluctuations contradict the idea that the coma dominates the light curve. Even the object's trajectory bends toward improbability, slipping within mathematical inches of Jupiter's Hill sphere like a stone skimming the lip of a cosmic trap designed for orbital capture. Each anomaly alone is a puzzle. Altogether, they form a message, not in the sense of intent, but in the sense of revelation. A revelation that the universe is still filled with physical regimes, structural principles, and mechanisms we have not yet identified, let alone understood. The closer 3I Atlas gets to Earth, the more its behavior refuses to collapse into any known category, as if the object itself is forcing us to confront the limits of natural explanation. And that is the frightening beauty of this moment. The possibility that humanity may be witnessing the first example of a class of interstellar bodies we have never encountered before. Objects that do not obey the simple binaries of comet or asteroid, natural or engineered, dust or jets, but something richer, stranger, and far more complex. Whether 3I Atlas turns out to be a fragment of an exoplanet's metallic core, an interstellar rocky body wrapped in unknown volatiles, a magnetically structured ejecta system, or something our scientific vocabulary has not yet invented, one fact has already become undeniable. This object has outgrown every model we tried to force upon it. It has made the solar system feel small again, mysterious again, alive again. And as it streaks toward its December encounter, growing brighter, sharper, and more disobedient with every frame we capture, it leaves us with a single, electrifying truth. The universe is not done surprising us. Whatever happens next, whatever new anomaly emerges tomorrow or as it races past Earth and dives toward Jupiter's domain, one thing is certain. The story of 3I Atlas is no longer just about a comet. It is about the moment humanity realized that our models were too narrow, our expectations too timid, and our understanding far from complete. The cosmos has delivered a visitor from another star system, and it is getting stranger every hour, as if inviting us, or daring us, to keep looking.